Python comes with a number of built-in data types. These include primitive scalar types like integers, as well as collection types like dictionaries. These built-in types are powerful enough to be used alone for many programming needs, and they can be used as building blocks for creating more complex data types. In this section we'll cover the basic scalar built-in types: int, float, non, and bool. We'll provide basic information about these now, showing their literal forms and how to create them. We've already seen quite a lot of Python integers in action. Python integers are signed and have for all practical purposes unlimited precision. Integer literals in Python are specified in decimal, but may also be specified in binary with a 0b prefix, octal with a 0o prefix, or hexadecimal with a 0x prefix. We can also construct integers by a call to the int constructor, which can convert from other numeric types such as floats to integers. Note that rounding is always towards 0. We can also convert strings to integers. To convert from base 3, use int and then 10000 as a string, comma 3. Floating point numbers are supported in Python by the float type. Python floats are implemented as IEEE 754 double precision floating point numbers with 53 bits of binary precision. This is equivalent to between 15 and 16 significant digits in decimal. Any literal number containing a decimal point or a letter E is interpreted by Python as a float. Scientific notation can be used, so for large numbers, such as the approximate speed of light in meters per second, 3 times 10 to the 8, we can write 3e8. And for small numbers, like Planck's constant, 1.616 times 10 to the minus 35, we can enter 1.616 e minus 35. Notice how Python automatically switches the display representation to the most readable form. As for integers, we can convert to floats from other numeric or string types using the float constructor, from an int and from a string. This is also how we create the special floating point values nan, or not a number, and also positive and negative infinity. The result of any calculation involving int and float is promoted to a float. Python has a special null value called non with a capital N. Non is frequently used to represent the absence of a value. The Python REPL never prints non results, so typing non into the REPL has no effect. Non can be bound to a variable name just like any other object. And we can test whether an object is non by using Python's is operator. We can see here that the response is true, which brings us conveniently onto the bool type. The bool type represents logical states and plays an important role in several of Python's control flow structures, as we'll see shortly. As you would expect, there are two bool values, true and false, both with initial capitals, and also a bool constructor which can be used to convert from other types to bool. Let's look at how it works. For integers, 0 is considered falsy and all other values truthy. We see the same behavior with floats, where only 0 is considered falsy. When converting from collections, such as strings or lists, only empty collections are treated as falsy. Converting from lists, which we'll look at shortly, and strings. In particular, you cannot use the bool constructor to convert from the string representations of true and false, because the string false is not empty. These conversions to bool are important because they are widely used in Python if statements and while loops, which accept bool values into the condition.